This work was actually supported and funded by US Army Lab and New Jersey Economic. Before I move to my technical part, I would like to start with my introduction. So, being a professor, my interest lies, or I have a soft corner on working on topics that is very new, very few people have worked on, or no one have worked on globally. So this is one of such topics. So at present, it might not be available in industries, but it has huge potentials, because of which soon it will be in industries, because we have worked these things in collaboration with multiple industries as well as institutes. So at present, I have collaboration with these institute. My motive of giving this talk is this highlighted in red one. I want to have more collaborations and add more names in this list. Few faces from my professional life: my PhD supervisor, my postdoc supervisor, three colleagues, old colleagues. These are my students. Not the white t-shirt, that's a professor in IT Madras. Remaining three are my students. Few more faces will be added soon, hopefully. Okay, so flow of presentation, I will talk on introduction, basic of composite, considering that everyone doesn't have domain in cold spray. So I will talk about that. And then I will briefly show some results. I will not go in detail considering the time limit. And I will show how to do the metallization. And second, I will show how to do the repair of composites by cold spray. So cold spray is a method in which millions and billions of small particles having micron in size are impacted on a substrate at a temperature which is much below their melting point. Now, due to this impact, those particles are deposited or attached on the substrate. Now, when millions of particles are deposited, it forms a layer. That layer can be treated as additive manufacturing or coating or repair, whatever we want. So that's the whole funda. And this few things are important. Velocity at which addition happens, or the range of velocity at which addition happens. That range is called deposition window. And the point at which deposition starts is called as critical velocity. And there are multiple parameters like diameter of particles, at what distance we're spraying, and all those things. I'm not going to. And everything is interlinked. Now, this technology, at least in Western country, it's quite used for metals. But when we started, or when our group started working on this, very few have worked for polymers. So we have worked in that directions. And so first thing that we explored is what is the mechanism by which that bonding is actually happening. Basically, there are two mechanisms which governs. First is plastic deformation and mixing. So basically elastoplastic flow, or we can also call it as ASI, adiabatic shear instability. So when particles impacting, there's a localized rise in temperature, due to which material melts in both sides and it gets plugged in. So that's one mechanism. For that, we have used multiple samples, not going in those details again. And second is, when your particle is relatively harder than your substrate, then mechanical interlocking plays the role. So the first layer, which is called as seeding layer, that happens because of mechanical interlocking. So if we want to deposit metals on polymer, that is the mechanism that we are looking for. So that some velocity window that we have calculated, and the range where we can deposit multiple materials on our peak substrate. Then this result shows how requirement of critical velocity changes with particle diameter. So it reduces and then it peaks again. So basically there's a balance of kinetic energy and energy required to deform material. And so it's a balance between those two. So that was basic of cold spray. Now I'm moving to metallization of composites by cold spray. So when we started this work, the idea was a big offshore wind farm is about to come in the sea zone of New Jersey. So we were working for them to explore when the entire farm is established and when there's a requirement of quick repair, on-site repair. So how can we do that? So that was the concept from where we started this work. So first, we again, this work is in collaboration with Penn State. So when we started, we tried to spray pure metal, and that was a disaster, well expected. When we are spraying pure nickel particles on our composites, it damaged all the fibers and all those things. So what we did, we came up with an innovative idea of modifying our particles. Now we have coated our particle with a polymer. So that single particle is in micron size and it is coated with polymer. And now we are spraying that particles. So now when we are spraying that particle, we can easily form a layer on which we can directly deposit metals, and we can get metallization of composite materials. Now the point is, to the best of our knowledge, there's no commercial supplier of these kind of particles. So we developed in our lab in collaboration with PPG. Again, those experimental results I cannot show here, but we have developed such kind of particles, and hopefully it will be out soon, or maybe in experiment also it will work good. So that's one thing. Next, I'm moving to, sorry, I'm not explaining all the results, those columns and all those things. Next is repair of composites material. So in repair, we primarily use nylon particles. So that's our lab setup. So first we try, before starting repair, we thought to check whether if we can deposit any particle, polymeric particle on composite where matrix is epoxy and fibers are glass. So first we deposited it on the undamaged sample, and we were successfully deposited till a height of 3 mm, which is quite good enough to repair any kind of composite materials. Then we this is SCM image where we have actually seen some anchoring and bonding between substrate material and these sprayed polymers. Then we have intentionally deposited, damaged our sample, and then we sprayed on that to repair it. And we were able to retrieve some of the results or strength, but we were not able to retrieve the entire strength. The reason is obviously we are repairing it using polymer, which is nylon, doesn't have any much strength on its own. So again, we came up with a new idea and we tried to modify our particles. Now we have particles of the dimension 200 micron in which we have chopped fibers. So these particles have shown a better results. Again, no commercial supplier as of now, to the best of our knowledge. It was developed in our lab. These are few papers, articles which are already published. Basically, these results are there. Thank you. I hope I completed in 10 minutes. Yeah, I'm open for questions. Where? Obviously. Exactly. Any other question?
Plastic on a thermoset product.
Yes.
What happens when the temperature goes up?
That's the point. It's a cold spray method. Here, the temperature doesn't goes that high.
Suppose it goes up to 135 degrees.
During
This thermoplastic will
during application.
Yeah, correct. As you said, selective application. Then change your material. Instead of spraying nylon, spray peak material or sun polymer, which can withstand that temperature range. So, I mean, if you have some thermal application, you have to choose material wisely. I hope I answered your question.
expensive.
Uh-huh.
This kind of application, peak is expensive.
I agree. Okay, so if I go in that direction, with PPG, we have developed another kind of particles, which is thermoset based. So when there's a particle, it has resin and matrix both. And when particle is impacting on the substrate, the membrane breaks and the cross linking happens and it forms a thermoset layer.
Room temperature.
At room temperature. But that's not my work, that's why I presented it here. Anything else? Yeah.
This utilization of fibers is already there for 10 years now in the field.
This method, it happens in seconds.
The cold immersion method, particularly.
No, the best part is in this method, it happens in second. The spraying or whatever we want, it will happen in second or minutes. The process is very fast. That's the first point. So now imagine you have a wind turbine blade where you want to spray it and something. If your wind turbine blade is not working for a day, you are losing lots of money. So with this method, we just have to carry a small settle and we have to spray it, and in 1 hour it's good to go. That was the main idea behind exploding these things.
Said that this process is not yet available, so that's why a question came. Because I myself has worked on that area for 2 to 3 years. Utilizing that carbon tow and blast fiber tow by spreading it and getting through the